So mitosis is important. Most of them divide, not all of them, because we need a nucleus, and therefore the red blood cells don't divide. This is a visual sort of making copies of the DNA, how it just gets unzipped, and then a DNA polymerase, they call that. But look at that, the word polymer. An ACE is an enzyme. Polymer means we make multiple, we make bigger molecules. So if you read that word, you probably can figure out what that means at this point. So I'm not going to even write it down. But here are the phases. So once the copies are made, then the process of these phases starts. So the prophase is when the chromosomes start becoming visible. This is a spaghetti ball. And then when they become visible, that's in the prophase. Also, in the prophase, we have the nucleus sort of going away and disappearing. Maybe, they also call this the prometaphase. This is not a process that is like chapter 1, chapter 2. It just goes through it. We just call it the phase. So we can describe it. So that's the prophase. Chromosomes made, nucleus disappear, and then the metaphase is very interesting. Now we have these two holocentrioles on each side, and now they create asters. They create tubules that go and reach towards the other side. And on the middle of that place, they'll call it equatorial plane, which is right here in the middle. That is where the chromosomes can line up and attach to the, and then these rays, these asters, they attach to that inner part of those legs, the centromere. So that's in metaphase, so all that line up. Then anaphase is when the chromosome halves separates, the centromere splits, and they're pulled towards each pole, those legs. That's in anaphase. And so now it's great because now we got a set of chromosomes on each side of the cell afterwards. And all we need to basically do is make sure more or less the organelles are distributed equally, and we split it apart. Because we can always make more of the organelles. So in anaphase we get that pulling going on, and then in telophase the chromosomes uncoil, the nuclear membrane is formed again, and then the cell cleaves. So that means it restricts on the side and it separates. So telophase in some ways is kind of like prophase in reverse. You make the spaghetti back from the chromosome, you make a nucleus around the spaghetti bowl, so you hold all that together. That's basically what that is. And then we got cytokinesis. Cytokinesis is the process also described like that. Cytokinesis is the cleavage where the cells really split up and make two daughter cells that are then complete.
Just to clarify, do red blood cells go through mitosis?
Red blood cells? No, because they don't have a nucleus. So all the blood elements are actually formed in the red bone marrow inside the bone. And so they are just created there. Red blood cell factor. Then their nucleus is sucked out. Meiosis is a process of making egg and sperm. What is unique with those is we can't have an egg or a sperm having 46 chromosomes. Because when they unite and combine to raise a baby, that's going to be a problem. Or then you go like what? 92 also. That will work. And so we have to have a process where, and this is actually a really complicated process, I'm making it very simple. But we have to have this process where we make two daughter cells, but not have the full genetic potential in each of the halves. Only have half of it. And so the way it goes more as a fundamental first step. To understand this, there's two steps. The first step and the second step. The first step is like mitosis, and we get a DNA copy. In the second step, we do not get a DNA copy without a DNA copy, and we then split the cells apart that way. And we got genes jumping around, things going on, and all kind of other things that happen during that process, but you pick that up in another class.
What's the time frame of meiosis compared to mitosis?
Oh, I have no idea. I would assume meiosis takes longer because of multiple steps. That's probably the right answer to that, but I don't know in terms of time frame.
How often is mitosis happening?
How often?
Yeah, like
Well, that depends. If you're looking at your skin, all the time. Because whenever you do something here, the cells fall off. It's not like it's not like they repel back. They fall off. They flounce off. That's one reason why it doesn't hurt us to do things like that. And so you've got about 30 layers of skin, dead sort of epidermal cells, the top skin cells. I think it's about 30 layers. And so they always have to be regenerated from the bottom up. So they're constantly active. So a lot of the cells that do skin or gut lining, they're really regenerative. Some, not at all. Nerve cells, they say nerve cells don't regenerate. We know that the hippocampal cells, which hold memory, they generate. They regenerate, but not when we're depressed. That's what's so interesting when learning and depression is really difficult to combine.
Things like free radicals that damage cells, do they damage them in the mitosis? Do they hinder mitosis?
No,
Free.
no, they damage the nucleus, they damage different parts of the inside as it is. They're like little, crazy things flying around, slamming into things, taking away an electron here and there, and that's why they're so dangerous. But I don't think it's only the mitosis process, that's throughout